Maximum difference between the increasing elements. It wants you to store the maximum difference, but there are some constraints that make the problem a little more difficult. But the idea is that you're taking nums of j and you're subtracting nums of I. Now, this isn't alluding to the fact that you have to have a nested for loop to do this. But the idea is you want to return the maximum difference such that the j is greater than I. So where nums of j is clearly the current element and nums of I is an element that has already passed. So this entire line is just referring to the fact that the element, the difference that you want to store on each iteration, if you choose to do it on each iteration, that difference should only be between an element that you're looking at and an element that has already passed. So you can't do the difference of, let's say, this element and this element. You want to store the maximum difference on each iteration between the element that you're looking at and an element that has already passed. And between all of those iterations, you want to return the maximum difference. So it does basically say that the maximum difference should be -1 in the event there is no maximum difference, because each difference that you can think of here, they happen to actually be negative. So we actually can't do that. So max diff can be set to -1. Now, the idea is, or the approach at least, was to iterate through the array, and for each element, store the maximum or the minimum value that the minimum value between the elements that have already passed. So as you're iterating through, you're updating a minimum value. So you're iterating through, and let's say you stop here, then your program should know what the smallest value is so far in the array. And then all you have to do for each element is you have to say, okay, if I subtract that smallest value, is that greater than had I done it for any of the other elements? So you basically have an int min, and that will store an integer dot min val. And you iterate for the length of the array. And you basically store the minimum. So if the current element that you're looking at is smaller than the minimum that your program knows to be true, then the minimum will essentially be set to that element. So all of this code here is just accounting for the minimum that you're basically the minimum value that your program knows for each iteration. And here, all you're doing is you're looking at an element and you're asking yourself, okay, if I subtract that minimum, so if I take the difference between the element that I'm looking at and the minimum that the program has stored so far up until this iteration, if that difference is greater than the max difference, then the max difference should be that difference, because it is the greatest difference that the program knows to be true thus far. Now you could add an additional here where you could say, okay, well, if nums of I is greater than the minimum value, because if it's smaller than the minimum value, then doing the difference would actually lead to a negative result. And then you can just return the maximum difference. And if there isn't a solution, then max diff will be set to negative regardless, right? Because you iterate through it, it wouldn't have a value. So if nums of I, if the current element that you're looking at is greater than the minimum that you're storing as you're moving through the array, then it only then does it make sense to actually have a comparison, right? So if it's greater than, and the difference that you've calculated for that element is greater than the maximum, the global difference that you've been storing, then it should be considered as the maximum so far. That's apparently the wrong answer. So I must have, if the element that you're looking at is greater than the minimum value and the difference is greater than the global difference, then the maximum difference should be that difference. So this is right. And then for the difference, you take nums of I and you subtract off the minimum that the program knows to be true. And if nums of I is less than the minimum that you know so far, then min should be nums of I. It seems here that no value in the array was smaller. There you go.